Welcome to KCD Bangalore, and let's talk chaos engineering. My name is Neelanjan, and welcome to this session on chaos engineering. And for the folks who are listening in for the first time, chaos engineering is a way to make your cloud-native applications resilient such that they don't break in production. So yeah, I guess most of you are here for that. So yeah, stay tuned with me to see how. Fine. Before we actually jump into the talk, let me just briefly introduce myself. I'm a software engineer at Harness, and I'm also a project maintainer for Litmus Chaos. So Litmus Chaos is a CNCF incubating project. And before joining Harness, I was at Chaos Native, the parent organization of Litmus Chaos, the founders of Litmus Chaos. And I'm a technical evangelist for chaos engineering, for its adoption and best practices. So yeah, with that out of the way, let's only talk about chaos. So before understanding chaos, let's try to discover the roots of chaos engineering. How did we even arrive here? Well, to know that, let's actually talk about the adoption of digital services in 2023. So we have this plethora of users, 5 billion, more than even 5 billion users who are using internet services on an average of more than 7 hours per day. So naturally, all the companies are now shifting towards cloud native to handle this humongous scale of operations. And that's how the term cloud native has come to be. Services that run and scale according to the cloud computing terms. However, now that these services have become cloud native, how can we assure that they are still reliable? Now, this question is relevant because, as you know, microservices are very diverse and complicated. You have these plethora of these microservices all talking to each other, all accessing network, and it even takes one of these microservices to go out in order for your entire application stack to collapse. So, the question remains how you can make it more resilient. Again, all these applications are being continuously pushing out their code. The cadence is even shorter than a week these days. So how can you ensure that you can do so in a continuous manner, more reliably every time? And lastly, we must appreciate that applications are bound to fail, because just to quote the Murphy's Law, anything that can go wrong will go wrong. So when an application actually faces an outage, when it actually goes down, how can we ensure that it is actually resilient enough and we are actually prepared to handle that outage? So before we actually get into the answer, I would like to actually deep dive into this question once again. So the cloud native dilemma says that we have our application stack over here. Your application stack sits on top of plethora of other services. You have your application dependencies, such as any databases you're using, any message queues you're using, and then the cloud native services themselves, like the CodeDNS, Envoy, Prometheus, whatever you're using. And then comes the Kubernetes services itself, etcd, and you name it, CodeDNS, whatever you're using inside your Kubernetes stack. And finally comes the platform infrastructure, whether you're using your bare metal stack or your cloud infrastructure provider. Such a long list. And just imagine, even one of them goes out, your entire application collapses, and you're paying huge bills. But we'll come to that. Now this problem is only accentuated by the sheer speed through which we are shipping code. Before, it used to be, once in a quarter maybe. Now it's every week. Make them 10 times faster. And again, you need to run them into 100x different environments. Now, I would like to actually talk about what this actually does. Impact of service downtimes. According to a report by Logic Monitor, companies with frequent outages and brownouts, service brownouts, that is degraded SLOs, experience 16 times higher operation cost. They need twice as many team members to cope up with it, and as a result, they have twice as much higher mean time to recovery. But it doesn't end there. More importantly, for the same companies, it was found out that 51% of these outages were avoidable, and 53% of the brownouts were definitely avoidable. But here's a big picture. According to a ITIC report, the cost of an outage per hour, the average cost, was close to anywhere between 1 million to 5 million. That was even beyond like all the fines and litigations, anything. Also, the average duration of an outage was close to 79 minutes. But beyond that, it also does irreparable damage to the loss of customer confidence, damage to the brand integrity, loss of employee confidence, and so on. Therefore, the need of the hour is to mitigate these problems, if not completely eradicate it. And how do we do that? Well, using chaos engineering. So what is chaos engineering? As I said before, chaos engineering is the practice of making our services more resilient by making sure that we are exposing them to some turbulent conditions before we are actually deploying them in order to assess their resiliency. So, in very simple terms, it can be divided into 4 steps. The first step, where you define your application steady state. It just means that when your application is working normally, it has all its metrics in a normal state. Second stage comes when you hypothesize something that can go wrong. Now, we all know the weak points of our application, predicted weak points where it can go wrong. So for those, we create an hypothesis. Again, we now perform those hypotheses in the form of experiments. We experiment on our application and check whether it goes down or not. And if it goes down, we go on to repair that. That is, we have found a weakness and we assure our code that, well, it should get corrected. So once it gets corrected, well, you have a resilient application. And this cycle goes on until you have a completely resilient application. So yeah, if you have right now understood that what is chaos engineering, what is the best way to perform a chaos engineering? Well, there are many ways in which you can approach chaos engineering because, to be honest, it's a culture-driven thing. It's like DevOps. The better your culture is, the more benefits you will reap out of chaos engineering. But here's a few. For example, it is a collaborative effort. So your developers and SREs should practice chaos engineering together, while developers should ensure that they are introducing chaos early on in their development pipeline. SREs should introduce chaos engineering in their production to ensure that they are shipping out resilient code. Then you should have a robust set of experiments so that your public and private chaos hub should be there, and you have a variety of different use cases that you can create out of chaos engineering. Lastly, you should ensure that it is integrated within your CI and CD systems to ensure that you are running these tests continuously to cope up with the scale of operations of your company. And lastly, you should definitely ensure that you have observability for chaos. Because let's be honest, guys, without observability, chaos engineering is simply chaos. So yeah, with that, we have completed a comprehensive list of what a good chaos engineering practice looks like. However, right now the question is, how can you bring it into your own organization? And that's where Litmus Chaos comes in. As I said, Litmus Chaos is a CNCF incubating project. It has a wide following among the CNCF masses, and it is a completely Kubernetes native application, which means that here the chaos intent is defined in a Kubernetes native manner using operators, and you use declarative patterns using the CRDs and custom resources in order to make the chaos. But don't worry, if you're not really acquainted with the CRDs, there is also a Litmus API as well as a Litmus Chaos UI called the Chaos Center, through which you can use the GUI and perform your chaos experiments. It integrates across Kubernetes, of course, and also a plethora of cloud platforms such as AWS, GCP, Azure, VMware, just to name a few. And of course, we started in 2017. It's an active development of more than 4+ years with more than 2,000 installations per day. And we recently actually crossed the 10 million Docker pull into our through our chaos operator image. So yeah, that speaks for itself. And of course, we have the 2.0 stable release with more than 50 chaos experiments. And of course, Litmus is adopted by giants such as VMware, NetApp, Intuit, Red Hat, just to name a few. So yeah, that brings us to the end of this lightning talk. If you haven't tried Litmus today and you are willing to bring more resiliency in your organization, do check out Litmus today. Excuse me. Thank you so much.
That's a wonderful explanation. So, like chaos engineering, it's you tell about how it works, everything. So could you please tell another one point, how startup can implement this? Because in startups, we are deploying by every day, we are maximum, we are going to production. So is there is an issue, it impact everyone. So how we can implement chaos in startups?
Okay, so By startups, I mean, I guess you're worried about the scale of operations mainly, that how quickly you can implement it or how scalable it is so that you can put it into all the different services. So that is fine. I mean, if you'll see, it has a agent-driven architecture actually, where you have a control plane and multiple agents being deployed to different sections where you want to, let's say, perform the chaos, different Kubernetes clusters. Also, it's really simple to get started with chaos engineering. As I explained, it's a completely UI-driven thing. I mean, your entire team can collaboratively work through Letbus Chaos. You can onboard your teams. You can have different chaos hubs. I didn't actually cover chaos hubs, but yeah, just for your information, it's like an open source marketplace for all these different experiments that you have. So let's say we have a public set of experiments that are in the public domain, but if you have a few set of experiments that are more relevant to you, and it is used throughout your organization, so you can have a private chaos hub which you can share among all your colleagues and then collaboratively do it. So yeah, it's more about how you bring in your expertise within chaos engineering. As I said, it's a culture-driven practice. I hope that answers your question.
Thank you.
Sure.